Good day! This is the reporting for the topic of conversion of algebraic expressions to English expressions and vice versa by Killian Bacos of CE and me. Language. Language is a systematic and daily tool used by humans in the means of communicating. It is a way to express thoughts and to easily understand them by writing, talking, or reading, as language was created to communicate to others. This pertains to what we use on our everyday lives, such as communicating with our family, friends, or acquaintances. Language is what we use to tackle them all and what we use in our daily life. But in mathematics, the ability to understand and translate numbers is an essential aspect in everyday events. It is crucial to translate algebraic expressions into common language because it makes easier for everyone not only to comprehend difficult mathematical concepts, but to apply it in daily mathematical problems. This pertains to when we have problems when talking about buying something. We can think about it as a mathematical expression, so we can calculate it or like solve it in a way that we can possibly with ease. And learning is made simpler by the clear explanation of these ideas, which also enables to apply math in real-world issues. And language of mathematics includes numbers, sets, functions, operations, and so on. The grammar, characteristics, and advantages of variables in mathematics. The mathematical notation used for formulas has its own grammar, which is independent of any natural language and is used globally by mathematicians regardless of their mother tongue. Mathematical language is also precise, concise, and powerful. Precise pertains to the ability to make very fine distinction or definition of someone, to be exact. Concise pertains to the ability to read things briefly or summarize. And powerful pertains to the ability to express complex thoughts with relative ease. Since we have different perceptions, thus making it more easier or more useful to express thoughts or complex thoughts with relative ease. And also, variables provide the ability to give what the problem is looking for a temporary name so that it can perform concrete computations on it to help discover its possible values. And we will talk this later since we will be doing our own examples in Spanish. And these commonly used mathematical symbols and sets. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the tens digit. The operations, addition, subtraction, multiplication, and division. The variables are A, B, C, X, and Y. Even though we can use much more, or we can use 24 words, 24 letters in the alphabetical order. This is the most used variables that we can see in our algebraic expressions. Special symbols are equals, greater than, less than, and pi. And set notations with N, W, Z, Q, R, C. That means set of natural numbers, the set of whole numbers, the set of integers, the set of rational numbers, the set of irrational numbers, the set of real numbers, and the set of complex numbers. And these are our mathematical symbols that we can use or what we use in all algebraic expressions or the arithmetic ones. And this is our basic English terms. As pertains to equals, is equal to, represents, is the same as, is, are, and the conjugation of the verb to be is similar to, equivalent to, exactly results in. In addition, plus, sum, total, added to, added with, added by, augmented, raised, more than, and increase put together. And subtraction, minus, difference, subtracted from, subtracted by, diminish, less than, less, decrease, separated. In multiplication, times, product, multiplied by, multiplied with, multiplied to, double, triple, twice, thrice, etc. In division, divided by, quotient, per, ratio, half, over, and overall. These are the basic English terms that we use in translating our algebraic expressions into sentences, and this is what we utilize when translating science. algebraic expressions, English expressions, the basics. For your perspective, what can we translate these numbers into? For me, it will be read by 7. Let's read it in the most elementary way or like the basic way. It says 7 plus x is equals to 12. But how we can translate it is into 7 added 2 by using our basic English terms, we can use added 2. So added 2 and a number is what we call a variable and is equals to 12. A word x can be translated into a number. So if you want to use a more complete sentence, a number can be used to represent the variable x than the word it is. Now the examples are x 5 plus y is equal to 20. 5 added to a number results into 20. The sum of 5 in a number is 20. And what are your thoughts about the second equation? You can use to read this as it is, so it will be read as x plus 3. But we can also read it as a number increased by 3 and the number augmented to 3. Next, in subtraction, we can also read it as like this. 10 minus x is equal to 15. 10 decreased by a number is equal to 15. The difference between 10 and a number is 15. And the second one, 6 minus x, the number subtracted from 6, 6 diminished by a number. In multiplication, 9 times x is equal to x. 9 multiplied to a number is equal to a number. And the product of 9 and x is same as x. In the second one, 13 times x is equal to 36. The product of 13 in a number is 36. 13 multiplied by a number is equal to 36. 8 divided by x is equal to 4. The quotient of 8 in x is 4. 8 half by number is 4. Not only the examples here pertains to what we can only translate it with, but we can also translate in more ways than what I will given as an example. But there are wrong things and right things in translating our expressions. Common math errors when translating. Without using proper commas and semicolons in dealing with sentences. In here we see 5 plus x is equal to 20. Without even translating the plus, our signs wouldn't be, or our sentences will be complete if we still use the sign as it is. That's why we have basic common English terms to translate our signs in the proper ones. And without using our commas and semicolons, since semicolons is what divides or arrange our values and our operations as it is. As examples, semicolons of equals to, it uses as the proper use of our grammars. Since it is a sentence, grammar is properly watched, so we can use proper semicolons and commas to properly express our own translations and sentences. And 12 divided by 6 equals to x. The quotient of 12 and 6 is a number, and the ratio of 12 to 6 is a number. And algebraic expressions take expressions, but with more complex phrases and keywords. Here, what can you think of reading our own equation? Starting off with x squared and 3, 4, and 10. It will be read as square of a number. Since we're doing squared, we'll be reading it as it is. So this is squared. And added 3 times the number, which pertains to the 3x. And increased by 4 equals to 10. And this is some of the long translations and what we can have in translating algebraic expressions in English expressions. Let's consider the use of semicolons and commas to properly arrange and sort out the values instructions. More examples are 2 multiplied the quantity of a number, that's 4. Double the sum of a number and 4. And the next one. This seems odd, but we can find its own translation of this. The product of sum of P and Q and with the difference of R and S. The result of multiplying the sum of P and Q by the difference of R and S. By here, we will reading our variables as it is, since it will be used to identify what the problem needs. As we read before, the variables sometimes will be read as it is to confirm or to give name, temporary name to something to compute to it. Often stating the variables given is needed as PQRS as it sounds, since we use to determine the variables used or given. The next is the sum of square of a number, 6, multiplied to a number, 9. A number squared added to 6 multiplied by a number and 9. And other one, the result of tripling the sum of x and 2, then subtracting the twice the difference between 4 and 1. Triple the quantity of a number, added by 2, the difference of 2, multiplied to the difference of 4 in a number. So one, the square of the number multiplied by 4, subtracted to the product of 6 times a and b, and then added to the square of b multiplied by 9. And the last one, the ratio of quantity by adding 5y and 7 by 4, the quotient obtained by adding 5y and 7 by 4. For our code, mathematics is only not about numbers, equations, computations, and algorithms. It is about understanding by William Paul Thurston. And this is where my presentation ends. Thank you and goodbye.